as an oxidizing agent. But it is not as strong as nitric acid. It is not as strong as nitric acid. देखो उसके बाद देखेगा क्यों ऐसे होता है. Okay, so now we write concentrated sulfuric acid. If you heat, what is the symbol of it? Delta. It decomposes to give you water, sulfur dioxide, and nascent oxygen. So because of this, hot concentrated sulfuric acid acts as an oxidant. Okay. So now we'll write here 1. Oxidation of non-metal. Okay, I'll write here capital A. So now we'll write 1. Carbon to carbon dioxide. It is carbon to carbon dioxide. So now you know how to do, right? H2SO4, heat, H2O, sulfur dioxide, oxygen. Okay, now carbon dioxide we require 2, so I shall write here 2. Who is going to provide oxygen? First equation, I shall multiply it by 2. Add it. So C 2 into H2SO4. It will give you 2H2O plus 2 sulfur dioxide plus. All right. Next is here only I'll write sulfur to sulfur dioxide. What I'll do now? I'll just see this and this. You do. Everything is written. Instead of carbon, you will write sulfur. And after that, you tell me. Everything I need not do. Okay. Right there. Fast. Don't take so much time.
Done, sir.
Okay. So what we will do now here? S. Okay. S. And it is here we will write C. 2 plus 1, 3. Sulfur dioxide. Finish. Okay. So now we'll write oxidation of metal. In nitric acid, we have found now there are two types of metals, which are more electropositive and others are less electropositive. So we'll write down here. Oxidation of more electropositive metal. Example, say it is zinc. So we know more electropositive metals, before being oxidized, it reduces the reagent. What should I write now here? Zinc plus H2SO4, it will give you zinc sulfate and 2 hydrogen. Okay. Now plus 2 hydrogen. Now this hydrogen is going to reduce sulfuric acid. So now I will write down here. Sulfuric acid decomposes to give you what? H2O, sulfur dioxide. See, this and this will combine to give you what? Partial equations are not difficult. It makes your life very simple. See here, 2H2O. Add this. Okay. So now we'll write here zinc. How many sulfuric acid? 1 plus 1, 2. 2H2SO. Then zinc sulfate. See here, 1 plus 1, 2. So 2H2O plus what? Sulfur dioxide. It is a very important equation. Finish, then I'll tell you.
Done, sir.
No. Dilute H2SO4 when react with more electropositive metal. Say zinc. I mean, just give me one example, but it is a truth for all other metals. Liberate hydrogen gas. See here. So zinc plus H2SO4 dilute. It will give you zinc sulfate and hydrogen gas. Remember. But concentrated, what does it give? It doesn't give hydrogen. It gives sulfur dioxide. But for concentrated H2SO4 on reaction with more electropositive metals liberate sulfur dioxide gas and not hydrogen. याद रखो. So it is zinc 2 H2SO4 zinc sulfate 2 water and sulfur dioxide. Don't forget, otherwise I'll break your head. Because I don't know I will whether meet or not. I'll be teaching you through online. Because even if your school they go for offline, because my house is not as big as your classroom of school. So in that case, I cannot accommodate so many students. Nah? Then again, you'll have problem. I also will have problem. So don't worry. I'll take your class. I'll send you video. I'll send you note, everything. And what are the things I did not send? Please list and send it to me. Sometime I forget. So I'll again send it. And if you wish to clear your doubt, let me finish flip block. We can go for Zoom or even Google Meet also. I'm always there to help you. Online I will continue with online only. Any problem you tell me. And better not to meet online only. You'll get unnecessary scolding. Na? Finish writing?
Yes, sir.
Yes, sir.
Yes, sir.
And so many numericals I have sent. Did you practice all these numericals? Please remember, I have taken around 40 hours to write. Consulted so many books. Okay, now oxidation of less electropositive metals. Oxidation of less electropositive metals. So in this case, less electropositive metals means they're weak. So sulfuric acid is going to oxidize. Right now here. So it can be copper, it can be mercury, it can be silver, all of belong to the same one. Less electropositive means whose reduction potentials are positive. And more electropositive means whose reduction potentials are negative and they are below hydrogen. Okay, so now I'll write here. So this will go by the principle of what? Dawn. First is what? Decomposition. This is decomposition. Then what? Oxidation. Then what is base? So this is base, this is acid. So it is neutralization. What will get? Salt and water, blood death. See now. DON. So cancel this. So हो गया 2H2SO4. So I'm there to help you, not to create some problem in your life. Okay. See, follow this one. So here I'll write note less electropositive metals like copper does not react with, this is very important, dilute H2SO4, even on heating also. If you heat also, then also it is not going to react. Why? It reacts with hot concentrated H2SO4 to liberate sulfur dioxide. Okay, so please remember this. Okay, does not react with dilute, but it reacts with hot concentrated sulfur to liberate sulfur. This question is here. So I'll write down again. Cu2H2SO4 giving you copper sulfate 2H2SO4. Remember.
Done, sir.
I told you to go through your book to see the examples and the name of the oxo acids of sulfur. Did you do? Tell. Don't tell lies and don't remain quiet. Huh? Hello. None of you.
Yes, sir.
Huh? You have done.
Yes, sir.
अच्छा name बोलो हम कब name से पूछेगा. What is your name?
Sir, Payal.
Pai. अच्छा. Then what about Grace? Have you done? Yes or no?
No, sir.
Then Gracie? Yes or no?
No, sir.
Gitanjali? No reply. Acha. Now, what Inam Karo, did you see? No. Ajnaya? No. Mr. Singh? No. I told you to see and then write in the copy. Huh? Rahul, where is Mr. Rahul Bhattacharya? I have not been able to contact him and not a single class he responds anything. In that case, I may have to report to your father. Is Rahul Bhattacharya in the class? Hello? Rahul is there. Rahul Bhattacharya, are you there in my class? Okay. So we will go for it. Oxo acids of sulfur. So here we will write formula and name. Structure. Oxidation state of sulfur. Basicity. It is very unfortunate. So 1 H2SO3. This is called sulfurous acid. Here also that you have to do something. Write the sulfur, put double bond oxygen and one OH. After that you see what is the formula. So you write like this. This, okay, I'll not write like this. I'll write it like this. And I'll write it like this. Okay, now let me see. Sulfur 1. How many oxygens are there? 3. 1 and 2 I have written. How many hydrogens are there? There are 2. I have written 1. So you have 1 oxygen and 1 sulfur. I'll write like this. And what you have here now? Double bond. Why? Because sulfur has 6 lone pair. Sorry, six electrons in this valence shell. Each bond is equal to 1 electron. See here. In this bond, 1 electron is given by oxygen, another given by sulfur. So each bond, sulfur has 1. So here you have 1, 2. Here you have 2 bonds. So 2 plus 2 is 4. 4 plus 2 is 6. What is the oxidation state of sulfur here? Plus 4. What is this basicity? I told only oxygen hydrogen bond breaks and give you H plus ion. How many are there? 2. So it is basicity. Basicity means number of hydrogen given in the solution. 2. H2SO4. What do you call it? Sulfuric acid. So here we'll write like this. Same. Okay. So now out of 4 oxygen we have written 2. So and out of 2 hydrogen I have written 1. I'll write one more. OH. Now 1 oxygen left, so I'll put down. Oxidation state is plus 6, basicity is 2. 3. H2 S2O3. This is called thiosulfuric acid. So here I'll write this, I'll write like this, I'll write like this, I'll write like this. See, 3 oxygen, 2 hydrogen, 2 hydrogen, 1 sulfur are written. What about the other sulfur? This is this. Because oxygen and sulfur belong to the same group. So what will be the oxidation state? +2. Okay, another problem is, I think you forgot how to calculate oxidation state. So I'll write down here. See here, how many elements are there? 3. So I'll write now A, then I'll write B, then I'll write C. How many there hydrogen? 2. How many sulfur? 2. How many oxygen? 3. Sum of the oxidation state of all the elements is equal to 0. I have to find sulfur, na? So I write 2. So you know, hydrogen is +1, 2B, oxygen is -2, 0. So 2 plus 2B minus 6 is equal to 0. So 2B minus 4 is equal to 0. So 2B is equal to 4. So B is equal to what? 4 divided by 2. To write plus, it is plus. Should I rub or you want to calculate? You want to write? Huh? Should I rub it? This one? Then you have to write some other place. Should I erase it?
Yes, sir.
Yes, sir.
Very good. That is, you know. So it's called thiosulfuric acid. Okay. Then 4. H2S2O4. Name is dihionous acid. This is a bit difficult for you. So we'll write like SC. I told you what to do first. First you write this. Okay. 2 sulfur are there. So I'll write like this. See, H2S2O4. But here, see, what is the oxidation state here? 2 electrons are still there. We'll write it like this. What is the oxidation state of this one? This is plus. Oh, sorry, its basicity is 2. I forgot to write. Here also it is 2. Then 5. H2S2O6 is called dithionic. Always remember there, as means lower, ik means higher. Dithionic acid. So it is same word. S. Now you have 2 more oxygen. One is here, other is here. This is +5. This is 2. Okay. So what is important for the exam? This is finished. Then I'll rub. Sorry.
So wait, sir, please don't rub number 5.
No, I don't rub. I don't rub. I'm not that heartless. Formula H2S2O7. This is called oleum. Okay. So we write, earlier we used to call it pyrosulfuric acid. Moment I say pyro means you should know by heating we have got. By heating sulfuric acid, we have got this one. Pyrosulfuric acid. Okay. Or these days we call it disulfuric acid, because you know, if you have, okay, I'll write down. And technically in industry we call it what? Oleum. What will be the structure? 2 sulfuric acid molecule has joined with each See, this is the one. This is two sulfuric acid. Look at that. By heating. This is this. And oxidation state +6, basicity is 4. Very sorry. This. Now, why do you call it disulfuric acid? Remember, in oleum, what did you find? If you add water, you get here 2H2SO4. Because of that, we call it disulfuric acid because it produces 2 molecules of sulfuric acid.
Done, sir.
Mm. Okay. Now the two acids which I'm going to write, both of them are important for structure. Remember, both in CBSC and in both, I have no idea about the ICSC. One structure is being asked from P block. So these two structures which I'm going to write is important. This is H2SO5. We call it peroxo monosulfuric acid. Okay, this has a common name. We call it ferrous acid. Okay, what is the structure? Please remember, this group is called peroxo. So this group is there. So we write it like this. We write it like this. We write it like this. How many are there? Oxygen. 1, 2, 3, 4. What is the other one? So you have a peroxide group. So this is important for your. This is +6 and basicity is 2. Then this H2S2O. We call it peroxo disulfuric acid. It also has another name. We call it Marshall. Marshall's acid. So here two
Excuse me,
sulfur.
sir.
Yes.
Sir, why is the basicity of number 6 4?
How many OH group it has? Kon? Nakarantali.
4, sir.
Then these are the hydrogen which breaks. Oxygen hydrogen bond will break to give you H plus ion. So if 4 OH groups are there, then how many it will liberate? Kano? How many?
4, sir.
Yes, so basicity is 4. Understood now?
Yes, sir. Thank you, sir.
Okay, now for this, I'll write 2 sulfur. Okay. So now 2 sulfur, this is linked with this. This. Okay. Now this. This is. See here. 1, 2, 3, 4, 5, 6, 7, 8. And 2 hydrogen. Oxidation state is +6. And this is. Okay. Acha, now I want to. Why did I write +6 for here? Let me calculate is oxidation state of sulfur. So it is H2SO5. So it is 2A plus B 5C is equal to 0. So 2A plus 1 B 5 into minus 2 is equal to 0. So 2 plus B minus 10 is equal to 0. So B should be how much? +8 or not? Then why do you write +6? Okay, don't write. Please remember, oxidation state of any oxygen is -2. But for these are peroxide or not? This is peroxide. Peroxide is -1. See here, I'll write now here. -2, -2, -2, -1, -1, +1. Hydrogen is +1. This is plus. So let me calculate now here. See, -2, -2, -2, -1, -1 is what? This is B. How many plus? Plus. So B is equal to minus. So therefore B is equal to plus. In this case, see here, this is -2, 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 this is peroxide and this is peroxide. -1, -1. This is +1, this is +1. So what should I write now here? For H2S2O8, I'll write now here. For 2 hydrogen +2. Now it is 2B. Now for oxygen, I'll write here 1, 2, 3, 4, -8. And this is -9, -10. So it is minus. So it is, how much it comes? Yes. No, I didn't make any mistake. No, no, no. 1, 2, 3, 4, 5, 6. Oh, it is -12, -13, -14. So it is 2B, 2 minus 14 is what? 12. Therefore, G is equal to 12 divided by 2 equal to plus. So nobody should make you fool. For peroxide is -1 and for simple oxygen is -2. Okay, done.
Yes, sir.
Yes, sir.
Okay, sir.
Yes, sir.
Okay, so now we'll go for group 16 finish. We'll go for group 17. If I tell you to read something, you don't read, then how can I finish your syllabus? Later on, don't blame. Some simple things so you can do by yourself. Group 17. What are the elements present there? Elements: fluorine, chlorine, bromine, iodine, and astatine. This is radioactive. Okay. Fluorine, chlorine, bromine, and iodine are extremely reactive and never found in free state. They exist as salts and hence these are called halogen. Means what? Means salt producing. Please remember the meaning of halogen. Astatine is not halogen. Second, electronic configuration. General electronic configuration. It is NS2 NP5. There is one short of octet.
Done, sir.
So now we'll go for physical properties. Physical properties, all of you know it. What is this? Atomic and ionic radii. The most electronegative. This series contains most electronegative elements of respective periods. So they all exist in anions. Iodine sometimes show cations, but it is anion. What should I say here? The atomic and ionic radii of these elements are smaller than corresponding group 16 elements. Why? Because of very high effective nuclear charge. Oh, right here. Along the period. Because of higher effective nuclear charge. This is along the period. It increases down the group due to addition of extra. Same thing I'm writing. Okay. B. Rest of the three will depend upon their atomic size. Ionization enthalpy. These elements have higher ionization enthalpy than group 16 elements. Then corresponding group 16 elements. Along the period. Why? Due to smaller atomic radii and higher effective nuclear charge. It decreases down the group. Why? Because the size is increasing. Down the group due to increase in their sizes.
Done, sir.
Okay. Now, next is what? Electron gain enthalpy. Same though. Electron enthalpy is negative. What should I write now here? the negative electron gain enthalpy values of these elements are more than corresponding group 16 elements, everything line by line is same due to their, here I forgot to write, due to their smaller atomic radii and higher effective nuclear.
Excuse me, sir, what did you wrote after enthalpy?
The negative electron gain enthalpy values of these elements are more than corresponding group 16 elements due to their smaller atomic radii and higher effective nuclear charge. Okay, finished.
Yes, sir.
Okay.
Done, sir.
That's wait. So now I'll write. Same thing I'm going to write. The negative value of electron gain enthalpy of group 17 elements decreases down the group due to increase in their sizes. Acha, now one exception is there, is very important for exam. See, in that case, what should you have if you go by this theory? Chlorine should have most negative value, then lesser will be chlorine, then lesser will be bromine, and iodine will be least negative. What we found is not like that. It has been found that electron gain value of chlorine minus 3 kilojoule mole less,
Hey, boo! Itar, itar kayo kami lang pagmugot. Wali
less
po.
than
Wali
that
po.
of
Wali po. Wali
chlorine
po.
minus 349 kilojoule mole. In fact, same thing we have found in case of oxygen and sulfur. See, so chlorine should have most negative, but you find is less than that of chlorine. So again, that they have drawn it for you. So as the size of the fluorine is small, when you need to put one more electron, there is huge repulsion is there, and that lowers the value. So what will we write now here? This is because of smaller size of fluorine atom, where a severe repulsion occurs between valence electron and incoming. Which consequently lowers the negative. This is extremely important for exam. Then comes electronegativity. Same thing. The group 17 elements are the most electronegative, are most electronegative. Along the period. The most electropositive elements are group 1 and most electronegative negative elements are group 7. It is due to their small size and very high effective nuclear charge. It decreases down the group. Why? Due to increase in their cycles. So I told you, ionization enthalpy, negative electron enthalpy, electronegativity depends upon atomic size and effective nuclear. So if you know that, other three also will. Now, if you club them together, then it gives you another property. It is called metallic property. So now we write metallic property. What is metal? Metal has very less ionization enthalpy. It does not become negative, so its electron gain enthalpy value will be 0 or positive, and it cannot pull others electron. So its electronegativity should be very, very less. So what should I write now here? The metallic property of these elements increases. So I can say another way. Metal is opposite to non-metal. So what I can write? Or non-metallic property decreases down the group due to increase in their due to decrease in their ionization enthalpy, negative electron gain enthalpy, and electron. But why do they decrease? Because of increasing their size. Because of increase in their
Done, sir.
Okay, now we'll go for their melting point and boiling points. Wait. melting points and boiling points. Okay. So now we'll write, you know that melting and boiling point increases with what? Increase in their sizes because with the attraction increases. So what we can write now here? Melting and boiling points of group 16, group 17 elements increases down the group due to increase in their what? Intermolecular forces of attraction, which increases with their size. So therefore, what I can write? Melting point and boiling point. Okay. For others, I did not write this. I forgot. So I'll write down, and you write some, find some space and write below. Melting point and boiling point is what? We'll write now here: chlorine, chlorine, bromine, iodine. Okay. So here I'll write chlorine, chlorine. Yes. Bromine, volatile. Volatile liquid. Iodine, sorry. Okay.
Done, sir.
Okay. Now, in ionization enthalpy, you write that I given you a summary right now here. Below ionization enthalpy, find some space to write. Write like this: F2 greater than Cl2, Br2, I2. This is for your quick revision before your exam, because factors are now you know. Then electron gain enthalpy. So which is more negative? Now you know. More negative is not chlorine, it is chlorine. So right now here, Cl2, F2, Br, sorry, Cl, F, Br, and I. Yeah, please remove this 2. Ah, 2 will not be there. Okay, now below electronegativity, please write this. Electron enthalpy. Now you write here So right now here, chlorine is most, chlorine, bromine, and bromine and iodine is almost same. Bromine and iodine. We'll write like this. All right. Now, here, all these things we have discussed in all these group 15, 16, 17. Here, in case of halogen, we have to study few more. See, what is that? What is the extra that you have to study? See here, in all these elements where, in case of halogen, they are all diatomic. In case of 16, only oxygen is diatomic. In case of 15, only nitrogen is diatomic, but others are not. Others are being held by single bond. Okay, they can, but in case of halogen, we find it is F2, Cl2, Br2, and I2. So here we have to discuss one more. It's called bond dissociation enthalpy. Okay. So G, bond dissociation enthalpy. See here, this is this. So you have to break it. The energy that is required to break the bond is what? It's called bond dissociation enthalpy, and it is directly inversely proportional to what? It is inversely proportional to bond length. Okay. So right now here, what is this definition? The amount of energy to break 1 mole of bond is called bond dissociation. We write this on as delta H. We'll find it is inversely proportional to bond length. So which is going to have maximum bond length? Iodine size is very big, so iodine will have least bond dissociation. So what you can say now here? In case of group 17 elements, bond dissociation enthalpy decreases down the group due to increase in the XX bond length. Why? As the sizes of elements increases down the. But here also one mystery is there. Right now here exception that is important for your. First I'll explain, then I'll write. Now, what is the exception? Before that, I'll let you tell you. See here. This is fluorine. This is a fluorine. Fluorine has 3 lone pairs. I'll draw it. 1, 2. See, size is very small. So the lone pairs are very close to each other. And because of similar charges, negative charges, repulsion is very high. It makes protein bond very, very weak. And you'll find it's amazed to know that fluorine bond dissociation enthalpy is not only found smaller than chlorine, lesser than chlorine, even lesser than bromine. So we'll write now here. It has been observed fluorine bond dissociation enthalpy is lesser than both chlorine and bromine. Why? It is because of the lone pair repulsion. Lone pair repulsion between 2 fluorine atoms, which make fluorine bond very weak. Thus, bond dissociation enthalpy. What is the symbol? Delta HA equal to what? You'll find here. Chlorine greater than bromine, then fluorine, then is extremely important for multiple choice questions.
Done, sir.
Okay. Now I'll come to the last. Color. All halogens are color. Okay. See here. Fluorine, fade. Chlorine, Finish. Bromine, reddish brown. Iodine, deep white. Why their color? Color of any substance is because of the electronic excitations. Okay, that is the valence shell electrons participate in electronic transition by absorbing visible light. The valence shell electrons of halogen molecule participate in electronic transition by absorbing visible light. Okay, finish. So tomorrow we'll discuss about this chemical properties.
Done, sir.
Okay, then bye for today.